All right, hi everybody. We're working through the quadratic functions and equations review. We're on question 21C. We're going to solve these equations here. I don't particularly like the way that equation looks, and so one of the nice things about math is I've got the freedom to, in many cases here, say I don't like your question. I will replace it with one that's similar to, but prettier. I'm going to multiply this whole thing through by 3 to get x squared equals 10x minus 21. And then because this is a quadratic, I'm going to bring both of those terms over to the left-hand side here. X squared minus 10x plus 21 is equal to 0. Okay, and I'm doing that, bringing it to the left-hand side here because I want the coefficient of the x squared term or the quadratic term to be positive. Now, normally what I would do at this point here, I would investigate to see if this is even factorable. And so what I would do is I would look for the discriminant. However, it's just comfort level with this. 21, the only factors of 21 are 3 and 7, and it just turns out that they do combine to get a 10 here. So I can actually factor this down relatively quickly to get x minus 7, x minus 3. And if I just think about it out a little bit, this would give me, okay, negative 3x, negative 7x together, that's negative 10x. Good. And then negative 7 times negative 3 gets me positive 21. Good. So what that means is if the product of those two is equal to 0, then it must be the case, sorry, and I didn't want to write it like that, I want to do that a little differently here. It must be the case that either the factor x minus 7 is equal to 0, in which case 0 times x minus 3 is 0, or x minus 3 equals 0, in which case 0 times x minus 7 is 0, which tells me that x is either equal to 7 or positive 3. And those are the two roots that I get from this equation.